In the previous session, we looked at a little bit more about Fourier series. And at the end, I had mentioned that we'll be looking at f of x equal to x square Fourier series. But we need to dig a little bit deeper in the sense we need to figure out whether we can arrive at some formulas for a naught, an, and bn. So let's do that now. And in the next session, we will look at f of x equal to x square. Okay, let f of x be a periodic function with period 2 pi. And we know the Fourier series formula. And here we have to figure out what is a naught, what is an, and what is bn. Or rather, we need to arrive at some expressions which will help us in evaluating these three. Now, the series is uniformly convergent and are integrable term by term in the interval minus pi to pi, closed interval. Okay, so let's integrate all the terms. Integral of f of x dx from minus pi to pi is equal to integral from minus pi to pi of a naught by 2 dx plus now summation and integration. Here they are commutative. So we take this out and take the integral inside the summation. So integral from minus pi to pi of an times cos nx dx plus summation integral from minus pi to pi of bn times sin nx dx. Now here we have to find a naught, an, bn. So let's take the first term. Let's take f of x dx integral to be equal to the first term alone. So integral of a naught by 2 dx from minus pi to pi is equal to, now a naught by 2 is constant. So we take it out. So in the integral from minus pi to pi, we have 1 dx, which is equal to a naught by 2 times x from minus pi to pi. And we know how to evaluate this. A naught by 2 times pi minus pi, which gives us a naught by 2 times 2 pi, which is equal to a naught times pi. Integral minus pi to pi of f of x dx equal to a naught times pi. And so we end up with a naught is equal to 1 by pi times the integral minus pi to pi of f of x dx. So we have arrived at an expression for a naught. Now we need to look at the next term, that is an. So again, we integrate each of the terms. Now here we need to somehow get rid of this first term, first integral, and the third integral. How do we do that? Now this is where you need to remember the important integrals that we had looked at. So let's multiply both sides by cos kx inside the integrals. What do we get? Integral from minus pi to pi of f of x times cos kx dx is equal to integral from minus pi to pi of a naught by 2 times cos kx dx plus summation integral from minus pi to pi of an times cos nx times cos kx dx plus summation integral from minus pi to pi of bn times sin nx times cos kx dx. Okay, now we apply those essential integrals that we had seen. Cos kx, remember, the areas cancel out. So that is 0. Similarly, sin nx times cos kx is 0 when n is not equal to k. And here also cos nx times cos kx integral is 0 when n is not equal to k. So let's take the case when n is equal to k. When n is equal to k, what happens? integral minus pi to pi of f of x cos kx dx equal to, the first term becomes 0, the last term becomes 0. Sin nx times cos kx integral between minus pi to pi is 0 when n is equal to k. Here it is not. So here it is actually pi. So we end up with, since we have said n equal to k, we have integral from minus pi to pi of f of x times cos kx dx is equal to ak times pi. That gives us ak is equal to 1 by pi times integral from minus pi to pi of f of x times cos kx dx. So again, we have ended up with an expression for a n, because remember n is equal to k. Now the last term. Again here we need to somehow get rid of the first two integrals. So this time what we'll do is we will multiply both sides by sine kx inside the integral. So we have multiplied each of these integrals by sine kx inside. So what happens? If n is not equal to k, sine kx is 0, cos nx times sine kx dx is 0, and sine nx times sine kx is 0 when n is not equal to k. So let's say n is equal to k. Then what happens? The first term, first integral becomes 0, the second integral becomes 0, and the third integral remains. And that is equal to pi. So we have integral from minus pi to pi of f of x times sine kx dx is equal to bk times pi. So which means we end up with bk is equal to 1 by pi times integral from minus pi to pi of f of x times sine kx dx. So we have arrived at expressions which are going to help us in evaluating a naught, an, and bn. So using these, we find a naught, a, and bn with respect to the Fourier series for a given function. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.